Hello, good afternoon, my dear students. Welcome to one more amazing session from Infinity Land. This is Suresh, Faculty of Chemistry. How are you all? How are you all, my dear bacho? Yes, I can see Ashwi. Good afternoon. After a long time, I could see you. Well, so welcome to our NEET 2025 most expected 1000 questions series. So we started this series a week ago. Hemant, hello. Altamash, hello. Botany के class क्यों नहीं होगी? Maybe the faculty is unavailable. They will take care of it. No worries, right? Yesterday, actually, I was with another schedule. That's why I did not come to the class. Okay, sorry for that. Thanks for concern asking. So that question indicates how regular you are in our sessions. Hemant, that's perfect. So आज से कुछ छुट्टी नहीं है ना? अल्तमाश कैसे? एंड आज हम चर्चा करने वाले हैं थर्मोडायनेमिक्स नीट एक्सपेक्टेड क्वेश्चंस पार्ट 1. So I just want to take thermodynamics 3 sessions for the discussion of the questions, because without thermodynamics question there is no NEET paper. You may expect direct one question, indirect another question. So 2 questions you can expect from this thermodynamics. Hi Suresh, how are you? How are you? So you are okay? Yes. Right, another student, it seems Monica should come. Ashwi, how are you? So how about your preparation, Suresh Kumar, Hemant? So far in this series of 1000 most expected questions for the NEET, we completed periodic classification, chemical bonding, structure of atom and practical organic chemistry. आपका फायदा मिला? आपका फायदा मिला? So I am expecting huge crowd for this particular thermodynamics part 1. है क्या ना? So you can see a number of students are coming. So again I just want to say, oath of the day, crack your NEET examination. For that, everybody please come to the class every day without fail and take a pen and paper, write along with me and solve along with me. If you are done well, I am going to appreciate. If you don't do correct, if you do anything gone wrong, I am going to correct you. For every question, I am going to give you a concept related to the solution, right? That's wonderful. For that, attend the classes. Please like the session, Arbar, and share with your friends and subscribe to Infinity Learn NEET YouTube channel. So we can see here Google Play Store में Infinity Learn ऐप है. ये Infinity Learn ऐप में आपका सब चीज़ मिलेगा, लाइव क्लासेस, मॉक टेस्ट, क्रिएट योर ओन टेस्ट 24/7, डाउट रेजोल्यूशंस. Okay, and I just want to say before going for this thermodynamics, there are 2 options. Whenever we start a particular topic, always you just see concept. First you want me to give a brief synopsis of the concept and questions shuru karna hai. Directly we will go into the question. Hemant, now you just give the answer. Yes, preparation is giving on these questions were really help, and these questions were NEET level, very helpful. Thank you very much, because हम हमारा तरफ से इतना मेहनत कर रहे हैं बच्चों लोग के लिए, कुछ भला करने के लिए. प्लीज टेक दिस एज एन एडवांटेज एंड डू अलोंग विथ मी एवरीबॉडी. सो अपलोड हेमंत कमेंट्स एंड फर्स्ट क्वेश्चंस और कॉन्सेप्ट एंड क्वेश्चंस. फर्स्ट यू वांट मी टू ब्रीफ द कॉन्सेप्ट, थोड़ा सा, सो दैट व्हेन यू स्टार्ट द क्वेश्चन आपको पता चलेगा क्या क्या करना है, कैसे करना है. You're all with me, right? Concept first. Thoda sa. It is not a concept class. 1000 series questions, right? So most expected question series में थोड़ा सा concept देने तो अच्छा होगा. That's the reason why I just want to start the class with a little bit of concept. Okay, in the thermodynamics you have a state function or you have a path function. I don't want to say system, surrounding, boundaries, types of system, open system, closed system and isolated system. So you just see state function, it depend on initial and final state of a system. It is independent on the path. Any parameter is a state function except heat and work are the path functions. You just keep in your mind. So a path function depend on path dependent. It depend on initial and final as well. Initial and final as well. So that work and Q. Only two path functions are there. Rest of the things are state functions. Acha? And units for the heat and energy. So work, heat, energy, anything interconvertible, calories is equal to 4.2 joules, and 1 liter atmosphere is equal to 101.3 joules. 1 liter bar is equal to 100 joules. 1 joule is equal to 10 rise 7 ergs, right? So these are the conversions. Sometimes in the calculation part we struck up there itself, right? And we are going into the intensive properties and extensive properties. Intensive properties independent on the amount of the substance. So short recapture बोले ना short ही करना पड़ता है. And example, density, temperature, pressure, molar heat capacity, specific heat capacity, viscosity, okay, surface tension, melting point, boiling point, freezing point. Hello Anurag Singh, good evening, good afternoon. मजा आया, very good, and you continuously keep discussing with me. Okay, अचानक आप गायब हो सकते हैं ना. So stay in the class, that helps you and your charting, and Hemant is also on the queue. Okay, so chart box में लगे रहो आप लोग here, come on. So this is intensive properties, contrast to that extensive properties. So depend on the mass, example like mass, volume, number of moles, entropy and enthalpy, Gibbs free energy, internal energy, everything comes under this. So you have state function, path function, internal energy, and intensive properties and extensive properties. Now golden rule hai. So this you can see in the textbooks, you can see in any other YouTube channel. Okay, Ilahi, good afternoon. ये golden rule आपके सिर्फ आपके लिए. So golden rule, extensive property upon extensive, ratio between two extensive properties intensive property होगा, and extensive property per mole or per mass is going to be intensive property. ताकि आपका enthalpy है ना, enthalpy is extensive property, but molar enthalpy is intensive property, molar heat capacity. So mind it, this is a noteworthy point. Next chapter, आज Thursday, Friday, Saturday सिर्फ thermodynamics चलेगा, Monday से equilibrium चालू है बेटा. अनुराग सिंह, right? So this is a golden rule, सबको फायदा उठाएगा, right? Next, heat, exchange of energy due to temperature difference around system and surroundings. A colder body है बेटा, hotter body है. Okay, so this is a body and this is a body. When these two are in contact, heat is going to be transferred from the hotter body to the colder body. That is the basic fundamental thing you need to know about the thermodynamics, and everybody knows it. And let us talk about heat is given into the system, Q is going to be positive, heat is released out of the system, Q is going to be negative. So it is a thermodynamic system, Q can be positive, Q can be negative. It's very important. It is endothermic process and it is exothermic process. Are you getting or not? Sign conversion is very important. And also sign conversion of the internal energy and work. This particular slide is self-explanatory for the system. If the heat is given, internal energy, and it is going to be work is done and work is out. So if his work is done on the system, W is going to be positive. If work is done by the system, W is going to be negative, and the heat given off by the system, Q is going to be negative, and the heat is given into the system, Q is going to be positive. So फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स का एप्लीकेशन जो ये स्लाइड के हिसाब से होगा, Exactly, it is in physics, but in chemistry, IUPAC, in chemistry we use this only, right? Why we use the different sign conversion in physics and different sign conversion in chemistry? It is going to be a debate, and we are not to discuss here. Okay, we are discussing most expected 1000 questions for the NEET 2025. Now, work area under pressure, PV graph. So, work done is equal to minus P delta V if an ideal gas is changed from V1 to V2 by compression or expansion. It is the formula to calculate initial and final volume. And expansion work, so delta V is equal to positive and work is going to be negative, and compression delta V is going to be negative, W is going to be positive. And these are the PV graphs. When the process is going on like this, always work done is equal to area of shaded part, and this is an expansion, and this is, you can see, this is called compression. Okay, now whatever the process may be, isothermal process ka hai. So you can see the area under shaded part is going to be the work done in this area. Okay, so reversible process, the process which takes place in number of infinitesimally small steps is called as a reversible process. Actually we study this only, it's actually slow process, and at any point it can experience equilibrium, and it is difficult to imagine and hard to achieve it. So this is about a reversible process. Irreversible process takes place in a single step, and equilibrium is observed in the initial step and the final step only, and P external is always constant for irreversible process, and P external is a variable. That is the key and catch point in this NEET examination. Theory oriented questions also can be seen better, and I am giving you the exact way forward how the things can be done. Okay, so it's an ideal process, reversible process. It actually all natural processes going to be irreversible. Hemant, Maunika is there in the class today. Beta Hemant, are you comfortable to understand Anurag and Suresh Kumar and Ilahi? So please students, if you have any doubts, you can put in the chat box so that we can have a discussion in the class itself, you know, right? So और थोड़ा आगे बढ़ना, and thermodynamic processes, ठीक है? So we have an isothermal process, change T is constant, the process which takes place at constant temperature, and isobaric process, P is constant and the process takes place at constant pressure, and isochoric process, the process takes place at a constant volume, and adiabatic process, the process that neither exchange of heat can be seen. So do not absorb heat, or it is taken place in isolated system. Okay, Ilahi, right? So keep asking doubts. Okay, so take a pen and paper, everybody can write the various formulas. Cyclic process, the process A is converted into B, is converted into C and D, and finally reaches to initial state. The process that takes place in number of steps and finally reaches to the initial stage is called as cyclic process. For cyclic process, state properties are all state functions change is going to be 0. Okay, change in internal energy, change in enthalpy, entropy gives free energy, but the path function is not equal to 0. ये काफी बढ़िया point है. Suresh, are you writing the things with me? Okay, Hemant denied to say directly questions में बोना. So Hemant now he is coming up with concept first. अगर concept करने के बाद क्वेश्चन शुरू करेंगे ना, बहुत अच्छा feeling आ जाएगा. Okay, next, internal energy. Sum of all kinds of energy of a system is called internal energy. You can't calculate the absolute value of internal energy. Rather, you can calculate the change in the internal energy. Delta U is equal to E2 minus E1. right? Internal energy, IE stands for internal energy, depends on temperature only, mind it, only, right? And change in internal energy of real gas is directly proportional to temperature and volume as well. For an ideal gas, it depends only on temperature because it do not have intermolecular forces. Exactly. And zeroth law of temperature, if a system is at thermal equilibrium, A is with thermal equilibrium with B, and in the other way, A is in thermal equilibrium with C. So we can also say B and C are also in thermal equilibrium. This is what you say is called a zeroth law of thermodynamics. It talks about thermal equilibrium. And let us go directly into the first law. Okay, beta? Arre beta. Okay. Hemant? Right. First law of thermodynamics. Based on conservation of energy, energy neither be created nor be destroyed, but it can be changed from one state to another state. Or you can say if some quantity of certain type of energy is disappeared, so equal quantity of work can be done. If some quantity of certain type of energy is disappeared, same quantity of another energy should be appeared, or we can say it is impossible to construct a machine, perpetuate machine which can work continuously without supply of continuous energy. So this is all about the energy conservation. Mathematically it is given as delta U is equal to Q plus W. So how do we say that? You can say let's say this is a system. This system internal energy initially is going to be U1. इसी वक्त में इसका Q amount of heat is supplied और कुछ work भी किया, work done is also done. So ताकि इसका internal energy पहले U1 state में थे, if you given this heat na, this much work na, so that its internal energy is changed to U2. Understand? So it is said that it is initial and the final. Initial is equal to the final is equal to initial itna tha, but you are adding this as well as in this na. You are adding this as well as this na. So that U2 minus U1 is equal to Q plus W. Q plus W. U2 minus U1 is equal to delta U is equal to Q plus W. This is what is called first law of thermodynamics, mathematical version of the first law of thermodynamics. Any doubt? And we are exploring this. कैसे करना, क्या करना? It's perfect. Right? Now, इसका applications आता है. You can see. So change in the internal energy is equal to W plus Q. Okay, work and heat. Okay, so the change in thermal energy or internal energy, you can say. This is a slide for beautification I have done. And let's see its applications. Types of thermodynamic process. We know it is an isothermal process. So in the isothermal process, temperature change is 0, internal energy change is 0. So that delta U is equal to Q plus W. So ये 0 होगा तो क्या होगा? Q is equal to minus W or W is equal to minus Q. Right? And reversible isothermal process, P is variable. So let us talk about the work done. Work done is equal to reversible process में देखो reversible process में minus nRT ln V2 minus V1 or 2.303 minus nRT log V2 upon V1. This formula is a very important formula. We are going to do some numericals based on that. बच्चों ठीक है? And similarly, V is inversely proportional to pressure. V is inversely proportional to pressure. So what happened? It comes in the reverse way. So V2 upon V1 comes upon P1 upon P2. That's it. Got it? Suresh, Ilahi. Especially concepts like thermodynamics, equilibrium, you need to revise the formulas once, especially for the NEET examination, then you can go with your question and answers. It is always recommended, no doubt about that. Now, irreversible isothermal process, directly we can use the W is equal to minus P delta V. So, delta V is equal to nRT upon P2 minus nRT upon P1. So, for vacuum, external energy is going to be 0, ताकि work done is going to be 0. So, pressure opposing force nahi hoga. So, for compression, work done irreversible, greater than work done reversible. For expansion, work done reversible is greater than work done irreversible. So, these are the micro level subject catchy points where you can understand a question from this NEET examination. ठीक है बेटा? Wow, wonderful, right? Okay, Suresh, come on. Next, adiabatic process. This is very important. So, Q, delta Q is equal to 0, so that W is equal to delta V, and also PV to the power gamma is equal to constant. This is the condition. PV is directly proportional. TV to the power gamma minus 1 is equal to constant. So, T power gamma P power gamma minus 1 is equal to constant. Okay, so this is the conditions for the adiabatic process. Everybody, please make a note of it. Jaldi. And Mayer's ratio, Cp minus Cv is equal to R for 1 mole of the gas. R is the gas constant, and Cp minus Cv is equal to Nr for n mole of gas. So, what is a Cp? Molar heat capacity at constant pressure, and Cv is equal to molar heat capacity at constant volume, and this is called Mayer's ratio, and Poisson's ratio gamma is equal to Cp upon Cv. So, the molar heat capacity of constant pressure, and you will be having the same table in the physics as well. Exactly, this is why. Yeah, why in expansion work done reverse is great and work done in the compression irreversible is great. So, in this case, the same question you are asked and vice versa, I will tell you. Okay, so the monoatomic gas degree of freedom is 3, and Cv and the Cp, it is going to be Cp-Cv Poisson ratio 1.67, and for diatomic gas, Poisson ratio is going to be 1.4, triatomic or polyatomic gas, the Poisson ratio is going to be 1.28, and this you might be knowing even from the physics, hai na? Clear? Fine. Now, work done in adiabatic process, I'll come back to you, Hemant, right? Work done in adiabatic process, that is given as the adiabatic conditions, and Cv delta T work done is equal to change in internal energy of the system. N Cv delta T, because at a constant volume, and work done in adiabatic Nr T2 minus T1 upon gamma minus 1. And work done in adiabatic also can be said the P2 V2 minus P1 V1 upon gamma minus 1. And this based on this, definitely you can expect a question. Okay, definitely you can expect a question from the NEET examination. Bacho? Yes, opportunities are waiting in the chat box, you can see. Just click enroll NEET test series, and that helps you a lot. Everybody click that link and you can experience the various facilities given in the NEET 2025 Infinity Learn test series pack. ठीक है? Now talking about isosteric process, delta V is equal to 0, then we can say delta U upon delta T at constant volume is equal to CV is equal to heat change upon T at constant volume. Similarly, isobaric also, and isobaric also, it helps a lot. For isobaric process, mind it, delta H is equal to delta U plus delta nRT, mind it. So here what is delta N? It is equal to sum of the number of gaseous moles of the products minus sum of the number of moles of the gaseous moles of reactant, mind it. So you have to take only in the gaseous moles. You have to consider only gaseous moles. Okay? If delta N is equal to 0, delta H is equal to delta U. If delta N is greater than 0, delta H is greater than delta U. If delta N is less than 0, delta H is less than delta U. Mind it, this based on this, so far for last decade 3 times the question has been asked. I am ready to give some questions based on that. Everybody take a note of it. Take a note of it, बच्चों. फटाफट जल्दी. Next question. And here enthalpy, we have seen the same thing here. Delta H is equal to delta U plus delta nRT. The same, delta N is equal to 0, delta H is going to be delta U. If delta N is greater than 0, then delta H is greater than delta U. If it is less, it is going to be like this. Fine. Heat capacity, the amount of heat that required to raise the temperature by 1 degree of temperature. Okay, for 1 gram it is called specific heat, for 1 mole it is called molar heat capacities. Okay, these are all molar heat capacity and specific heat capacities. Specific heat capacity, S is equal to Q by M delta T, and mass of the substance, and molar heat capacity Cm, Q is equal to N delta T, N is equal to number of moles. And this Cm is going to be Cp and Cv, molar heat capacity at constant pressure, molar heat capacity at constant volume. No, this is a chemistry class. It's not a Kashmiri class. If you are from Kashmir, you welcome to the class. Okay, you can say limitations of first law of thermodynamics. I don't want to discuss total thermodynamics. टोटल थर्मोडायनेमिक्स डिस्कस करने का आपको चलेगा कम से कम 12 घंटा. Okay, so let us go ahead with, it does not explain the feasibility of a process under given conditions. Feasibility का मतलब क्या है? ये process ये हो सकता है, नहीं होगा. Okay, ये reaction आगे बढ़ेगा, नहीं होगा. So that is not explained here. And also second law of thermodynamics. So once you learn about what is the limitation, then you can go with the second law of thermodynamics. Second law, yeah. So beta, this is a classroom, and please maintain the classroom decorum, and you please don't come in the middle of the class and don't pass any unnecessary comments, which is not actually good. Students, hundreds of students every day, they are coming and they are getting benefit of that. Hemant, come on, and Suresh Kumar and Ilahi. Right, it states that the direction of the flow of heat, right? And all the natural processes in the universe are irreversible process and spontaneous. And due to spontaneous process, entropy of the universe increasing continuously. Delta S total supposed to be positive, it is greater than 0. Okay, just want to say here, a process which has a self urge to proceed by itself is what is called as a spontaneous process, and opposite to this is called a non-spontaneous process. So, does spontaneity directly influence entropy directly influences spontaneity? Yes or no? We can't say that. So, not only entropy change but also enthalpy change together can different limit the criteria of the spontaneity depend upon the temperature. That is given by Gibbs-Helmholtz equation. We will discuss about. If delta S total is greater than 0, it is said to be spontaneous. So, it is as of entropy is concerned. ठीक है बेटा? And delta S is less than 0, it is said to be non-spontaneous. Delta S is going to be 0, is going to be equilibrium. So, what is entropy? It is the degree of randomness. Okay, entropy of the universe is equal to entropy of the system plus entropy of the surroundings, and for an irreversible process it is going to be greater than 0, that I want to say. So, measure of degree of randomness of disorderness of the system, and more the randomness, more is the entropy, and delta S is equal to Q reversible by temperature. And I just want to ask a question, as the temperature increases, entropy change increases or not? No. That's very important. I just want to give you. Excuse me, you please focus in the class. So, entropy increases, pressure decreases, entropy increases, temperature increases, entropy of the molecule increases, as entropy of the substance also increases, and on dilation entropy increases, on mixing entropy increases. These are the things. But which has more entropy? Definitely we can say S1 and S2. S2 is greater. S2 is greater. Are you getting or not clear? Are you getting or not clear? Now I just want to give you 10 joules of energy, 10 joules of energy, simultaneously 10 joules of energy separately. Understood? Now, इसका जो एनर्जी है, एंट्रोपी है, S1 डैश बढ़ गया, इसका जो एंट्रोपी है S2 डैश तक बढ़ गया. So, the difference here, delta S dash, the difference here it is delta S2. Now, could you say delta S2 is greater than delta S1 or delta S1 is greater than delta S2? मैं क्या बोलना चाहता हूँ, delta S1 is greater than delta S2. This is a super awesome point. Everybody should understand this. क्योंकि चेंज इन एंट्रोपी अगर कम से कम टेम्परेचर से बढ़ रहे, इसका वैल्यू भी बढ़ जाएगा. अंडरस्टैंड? सो जिस सिस्टम कम टेम्परेचर से एंट्रोपी चेंज बढ़ रहा है, इसका ज़्यादा होगा. सो ये कम होगा, ये ज़्यादा होगा. ये करेक्ट स्टेटमेंट है कि ना? क्लियर? It's a very important concept. So, this is the way you need to study thermodynamics. Clear beta? Right, आगे बढ़ेंगे. Entropy change in a reversible process. Entropy of the universe is equal to 0. Entropy of the system plus surrounding is equal to 0, and system is equal to minus surrounding for reversible process. So, this is true for reversible process. Hemant? And for irreversible process, आपका जो ये बोल रहे हैं ना, second law of thermodynamics, entropy of the universe always increases for irreversible process. For irreversible process, Hemant. And entropy for a system at a given temperature, entropy of the gas is greater than liquid is greater than solid. Entropy of the pure crystalline solid at 0 Kelvin is 0. Third law of thermodynamics, right? So this is the way you have to connect with the thermodynamics one to another, right? Clear beta? Now, calculation of entropy change for an ideal gas. So, a ideal gas ka is very important, super important formulas. Hemant, as you requested me, I thought you definitely requested me, and you already requested. These are the formulas. Change in entropy is equal to NCV ln T2 upon T1 plus N R ln V2 upon V1. And entropy change NCP ln T2 upon T1 and R NR ln P1 upon P2. And you can say for an isothermal process, NR ln V2 upon V1 is equal to NR ln P1 upon P2. Ln x is equal to 2.303 log to the base 10 of x, mind it. Right? You can solve the question like this. Ln x is equal to 2.303 log to the base 10 of x. This can help you. And for isothermic process, entropy change is equal to NCV ln T2 upon T1. And for isobaric process, NCP ln T2 upon T1. And reversible adiabatic process, delta S is equal to Q reversible by temperature is equal to 0. है ना? लिखा? Now, entropy change during a phase transformation. Phase transformation means solid become gas, gas become liquid. So, change in the physical state. So, for the fusion, solid become liquid, delta S is equal to enthalpy of fusion upon temperature. Enthalpy of vaporization upon temperature is equal to entropy of vaporization. Entropy of sublimation is equal to enthalpy of sublimation upon temperature. Entropy change in a chemical process, delta S is equal to delta S product minus delta S reactant. है ना? So, what not? Total formulas are one side it is swiped, and spontaneous process and non-spontaneous process discuss किया चुका है ना? And Gibbs free energy, the capacity of system to do useful work is called as a Gibbs free energy change. The decrease in whose energy is actually used for the work done is called Gibbs free energy. Delta G is equal to delta H minus T delta S is Gibbs-Helmholtz equation. If delta G is less than 0, delta G is going to be negative, then the process is going to be spontaneous. Delta G is equal to 0 equilibrium, delta G is greater than 0, the process is going to be non-spontaneous. Okay. So, this is the condition where directly and indirectly we are connected to this particular slide in the organic as well as inorganic chemistry, bachcho. And if delta H is negative, delta S is positive, then delta G is going to be spontaneous at any temperature and vice versa. Based on this, in 2024 also in the NEET examination by question pucha. Every year, if you get a question, definitely in 2025 also I can give you a promise that you are going to get a question. So, everybody take a snap of this. Take it, 3, 2, 1, bacho. Make it, jaldi. Hemant, come on. Now, super note. It's a super note. Relation between delta G and delta G naught. What is delta G? Delta G means at 298 Kelvin, 1 atm pressure. Delta G here is going to be any temperature and any pressure. So delta G is equal to delta G naught plus 2.303 RT log Q. You know, at equilibrium, QC is equal to KC, इसमें डालो, and delta G is equal to 0 and delta G naught is equal to at equilibrium minus RT ln K, and delta G naught is equal to minus 2.303 RT log Kc. That is the equilibrium chapter. I said one question directly from thermodynamics, one question indirectly from other chapters. So it is related to other chapter and we are connected to thermodynamics. You know, right? So shall we start the questions? Shall we start the questions? Delta G and work. Delta G is equal to minus non-expansion work. Delta G is electrical work minus NF E naught cell. So thermodynamics is connected to electrochemistry as well. So everybody, before going for the questions, you all just thumbs up and yes, Hemant. And which of the following is not a state function? Jaldi. Which of the following is not a state function? Heat, internal energy, enthalpy and entropy. So not a state function. Not a state function. It is supposed to be either Q or W. I told you, these only two path functions. So my answer is going to be here A. Your answer satisfies. You are the best. You are the best. And और एक क्वेश्चन है, heat and work are path functions. अच्छा किया बेटा. Now which of the following is not an intensive property? You just see, you come up with now lot of confusions. You know the subject, now you apply, you are going to have various types of different concepts. Okay, now it is going to be entropy, pressure, temperature and molar volume. Molar volume, temperature, pressure and entropy. Entropy, how? It is going to be, yes it is. As far as the definition part is concerned, if it is taken a molar volume with a different value and gaseous system place it in a pressure P1 and volume V1 and the temperature T1, it has undergone thermodynamic change where temperature is remaining constant. Temperature remaining constant. A process क्या होगा? Temperature remains constant. Delta T is equal to 0. So such process is going to be isothermal process. Sir, thermodynamics से questions इतना easy आएगा ना? हाँ पक्का बेटा. ISO thermal नहीं ना, isothermal. Next, it is B. Perfectly it is B. Next, based on the first law of thermodynamics, which of the following is correct? We discussed the concept now. The same concept is coming over here. For an isothermal process, Q is equal to plus W. For an isochoric process, Q is equal to minus Q. And for adiabatic process, delta U is equal to minus W. For cyclic process, Q is equal to minus W. What could be the answer? Now apply the first law of thermodynamics. So delta U is equal to Q plus W. है ना? First law, which of the following is true? For an cyclic process, isothermal process, delta U is equal to 0, Q plus W. So Q is equal to minus W, W is equal to minus Q. ऐसे हो सकता है ना? And which of the following is correct? For cyclic process, Q is equal to minus W. for an adiabatic process and isothermal process, it is going to Q is equal to plus W कैसे होगा? गलती बात है. Are you getting or not? Yes, for cyclic process का है. For cyclic process का है. Understand? Next. So this is your explanation. Right बेटा? अरे बाकी बच्चों का आ गया. Maunika is not there in today's class. So please interact with the Suresh Kumar. Come on. Next. Exactly. In a process, work is done at the expense of internal energy. What is work is done on the expense of internal energy? That's what Hemant you want to write. The process is going to be work is done on the expense of internal energy. Expecting an answer, bachcho. It is direct application of thermodynamics. It is going to be adiabatic process. For adiabatic process, delta U is equal to Q plus W. For adiabatic, Q is going to be 0. So delta U is equal to W. Okay, so it is going to be adiabatic process. Understand? Clear? That's what it is mentioned here. Perfect. Or a question. In a reaction, all the reactant products are in liquid. Then I want you to give the answer in a serious way. Just a serious way. We know that delta H is equal to delta U plus delta N in the gas state RT. Delta N gas state is equal to sum of the number of moles of the products in the gas state minus sum of the number of moles of the reactant in the gas state. Everybody is in the liquid state. Therefore, delta N gas is going to be 0. If you put this value as a 0, so ताकि आपका मिलेगा delta H is equal to delta U. So delta U और delta E दोनों बराबर हैं. Understand? Yes, you want to say C. That's perfect. That's perfect. Exactly, Hemant. Exactly. Your answer is going to be C. Appreciated. Perfect. Perfect. And it is a system absorbs 10 kilojoules of heat and constant volume, and its temperature rises from 27 to 37 degrees centigrade. The value of change in internal energy. Who is going to do this? It is a first numerical in the thermodynamics. Everybody, come on, do it. Everybody, come on, do it. Delta U is equal to delta H plus, okay, ये वाला direct लेना, okay, Q plus W. That is going to be Q plus W. अब कर सकते हैं, कौन सा आंसर होगा? 27 to 37. 10 degree rise is done. 10 kilojoules of heat is absorbed. Waiting for you, waiting for the guys. Now here it is going to be 10. जितना energy दिया ना उतना काम करेगा. So you can say according to the first law of thermodynamics आपका delta is equal to Q plus or minus W. Work is done by the system, W is negative. Work is done on the system, W is positive. So at constant volume, work done is equal to 0. कुछ काम नहीं करेगा ना. So delta U is equal to Q. So Q is delta 10 kilojoules. Internal energy is also going to be 10 kilojoules. समझ में आ रहा है क्या? Maunika, good afternoon. My health is not good today. You will watch the recording. It's okay. So take care, बच्चों. Health during this situation is also very important. Very important. Okay, as a season you are transforming into winter to summer, so definitely viral infections will be there, maybe in other reason, I don't know, but it is you, it is your health and you have to take care of it. Okay, as a teacher I just want to give you kind of advices for your preparation. So आप अच्छा पढ़ाई किया, okay, आप अच्छा बच्चा है, लेकिन एग्ज़ाम करने का वक्त में अगर तबीयत ठीक नहीं होगा तो क्या करूँ? So your health is top most priority and get well soon. Thank you very much and God bless you. Okay, next. A system absorbs 10 kilojoules of heat and does 4 kilojoules of work. The internal energy change. अरे बेटा प्रीवियस जो क्वेश्चन है ना, ये क्वेश्चन दोनों बराबर दिखते हैं, लेकिन आपका सवाल ये अलग है. कर लो पहले पहले पहले. So I'm expecting you to give the answer. Thank you, Monica. Right. Decreases by 6 kilojoules, increases by 6 kilojoules, decreases by 14 kilojoules, increases by 14 kilojoules. This kind of questions, you know, it gives an awesome experience and boosts a lot of confidence. Okay. So before you come to the class, Monica, I was expecting you and announced in the class also your name. Okay, take care, and if you could able to give the answer, I would be very happy. And Hemant is already given D. Okay, so what could be your explanation for this? Just I want to know, Hemant. So in the next class onwards, I may just keep a poll in the class so that everybody can vote it on. Okay, now you can say it is going to be B. Kaise? According to the first law of thermodynamics, delta Q is equal to U plus W. Okay, so 10 kilojoules of heat is supplied and 4 kilojoules of work is done. Okay, so that 10 is equal to delta U plus 4. So it is work done. Does system is done. So that it is going to be minus 10, 10 minus 4. So it is going to be 6. So it increases by 6 kilojoules of energy. Both positive. Yes, exactly. Understand? Here the sign conversion can cheat you like anything. Cheat you like anything. Mind it. Done on the system. Next. 2 moles of helium gas undergo reversible cyclic process as shown in the figure. Assuming to be gas is ideal, what is the work done in the process C2D? C2D. C2D. A process kya hoga? So here the pressure is decreased. Okay, temperature is constant. Isothermal. Isothermal. Do it. Two atoms say, so from A to B, 1 ATM to 2 ATM, from B to C, 2 ATM to 2 ATM, so isobaric, and C to D, and it is 2 ATM to 1 ATM. So temperature is decreased and 400 Kelvin is maintained. So you are asked to C2D. Okay, expecting an answer, bachcho. ओके इसका आंसर आता है आपका सरप्राइजिंगली -800 और ln2 आपका आंसर चाहिए। देखो C2D इज आइसोथर्मल प्रोसेस क्योंकि इसका टेम्परेचर कांस्टेंट है, so that work done is equal to -nRT ln P1 and P2. So -2 mole of the gas, 2 mole of the gas are, and temperature is 400 is given, 400 and ln2, and that is 2 upon 1. So that is going to be 2. So I just want to say 2 into 400 is equal to 800 and R ln2 -800 R ln2. Understand how to solve this question? So this is your answer and this is your solution. Got it? Clear बच्चों? Now दे सैम्पल। सो नीट एग्जामिनेशन में आपका क्वेश्चंस ऐसे तरीका आने का संभावना है, यू हैव टू चेक इट। ये सिस्टम इज ए सैंपल ऑफ लिक्विड इन थर्मली insulated container. Of course you can say it's a calorimeter. Okay, hi, hello, something is name is given, even I can't read it. Okay, just follow this, and is stirred by a motor and taking liquid as a system for the process, choose the appropriate option. So thermally insulated. So thermally insulated में क्या चलेगा, internal energy बढ़ेगा ना। Adiabatic process, you have to take the adiabatic process for this. Okay, for this what is the answer for this? Clear? Give the answer jaldi बच्चों। Doctors, my dear doctors, come on. My dear doctors, you can say the answer is going to be work done is greater than 0. Now we can say it is stirred, since energy is provided, positive work is done on the system. So since it is isolated, adiabatic Q is going to be 0. So for the according to the first law, so delta U is equal to Q plus W, and Q is equal to 0, isolated system Hemant, and W is equal to greater than 0, it is stirring, and change in internal energy is greater than the heat. Okay, so answer for this question is D. Everybody, hope today you enjoyed the class like anything. You enjoyed the class like anything. Okay, tomorrow we'll come up with more number of questions from the thermodynamics. Get ready. We'll see more heat capacity related problems and Gibbs-Helmholtz related problems. Hemant, you enjoyed? Maunika, right? So please like our session, share with your friends, and subscribe to Infinity Land NEET YouTube channel. Signing off, Suresh. Thank you very much. Bye bye.